In the previous class, we had discussed regarding this battery ignition system, and we had seen the various parts which are associated with the battery ignition system. And I think we are left with the last part, which is the spark plug. Okay, so if we see the diagram of the spark plug, we can see so this is the view of the spark plug. Okay, it usually consists of two electrodes. One is the central electrode here, and another is the ground electrode. Okay, the electrode which is grounded, and you can see that there is a connection, and this is from the secondary winding. This connection is from secondary winding. Okay, so actually it is from the distributor coils. Okay, this connection is actually from the distributor coils, and we can still write here distributor coils, and that distributor coils, and this connection is from the distributor. Okay, connection from distributor, और distributor को जो connection मिलता है, that is from the secondary windings. I told you that suppose in a 4-cylinder engine we have 4 cylinders, and there will be 4 spark plugs responsible for the combustion. And I told you that at a time हर किसी में combustion नहीं होता है. There is a particular firing order, and in case of the 4-cylinder engine, this is the firing order: first, third, fourth, and second. That's why I showed you yesterday the distributor coil. ठीक है, तो मैंने distributor में दिखाया था क्या होता है. There is a rotor which rotates, and we have these distributors at the periphery. Okay, so yesterday we had seen that, and it comes in contact with a particular distributor at a time, and that will activate a particular spark plug at that time. Okay, so in the spark plug, what we have a ground electrode, and we have a central electrode. So you can see that this connection is with respect to the central electrode. और इन्हीं के बीच में क्या हो जाता है, हाई पोटेंशियल डिफरेंस इज क्रिएटेड. ओके, यू कैन सी दैट इनके बीच में क्या हो गया क्रिएट. There will be a high potential and difference that will be created between these two electrodes, and you can see that there is a gap between these two electrodes. Okay, there is a gap between these two electrodes, और उसी में क्या हो जाएगा, ionization of this gap will take place. Okay, इसमें भी जो भी air होगा in this column, that will get ionized. Ionization of the gas in this gap. That's why we require extremely high voltage. Okay, so normal voltage ionization of this gas column won't take place. Okay, since we have very high potential difference here, therefore ionization of the gas in this gap will take place, which will further produce a spark. It will produce a spark which is required to combust the, you can see that the spark here is produced, required to combust the mixture. Okay, so how does the spark plug again look like? ये आप लोगों ने देखा भी होगा. Okay, let's put it in the next. This is how the spark plug actually looks like. If you have seen the overhauling of the engine, this is the complete view of the spark plug. So we have discussed all the parts which are associated with the ignition system. Okay, so we have discussed all the parts associated with the ignition system, and let us see how this ignition system will work. So first of all, what will happen here is there will be a primary current from the battery. Okay, there will be a primary current from the battery. So we can see that when the ignition switch is turned on, when the ignition switch is turned on, Okay, the primary circuit gets closed. The primary circuit gets closed and current starts flowing through it. Okay, the current will start flowing through it. Okay, what will be the result of this current? This current, which is known as the primary current, it will set up a magnetic field around the soft iron core. Okay, we can see the magnetic field in this image. Okay, you can see that on the account of the primary current. So what is the consequence of this primary current? This current, which is known as primary current. Okay, this current, which is known as primary current, sets up a magnetic field around the soft iron core of the ignition coil. Okay, so the main idea of this circuit is that what we have to do, we have to develop the EMF. Okay, the EMF should be quite large, or quite large EMF कैसे develop होगा? If you can see from the basics, you know these things. EMF is proportional to what? A rate of change of the magnetic field. Okay, it is proportional to the rate of the change of the magnetic field. Therefore, what we do here is we have to develop an abrupt change in the magnetic field. The thing for which we have developed this circuit is to develop the abrupt change in magnetic field. Okay, also the number of turns will be quite large in the secondary winding. Therefore, when we get the abrupt change in the magnetic field, that means what? Abrupt change in the magnetic field means that this dt tends to zero. Okay, है ना? Suppose अगर हम force की बात करते हैं, force is what? A rate of change of the linear momentum. Okay, force is a rate of change of the linear momentum. So how will be the more force we get? We have to develop a large change in momentum. Okay, or we can develop that change in momentum in a very short time. Okay, by that thing we will get this large amount of force. Similarly, we can relate here, the EMF will be quite high if we can say that the magnetic field change becomes abrupt. That's why we have employed this circuit here to get the abrupt change in the magnetic field. So see here what will happen further. ओके, अभी तक क्या है? अभी तक जो है कॉन्टैक्ट ब्रेकर के जो पॉइंट्स हैं, जो मैंने कल आपके साथ डिस्कस किया था, द कॉन्टैक्ट ब्रेकर पॉइंट्स आर इन कॉन्टैक्ट. Okay, there are two points मैंने कहा था, one is the fixed and another is the movable. They still are in contact. But what can happen here is after the contact breaker, the contact between those 2 points breaks, what will happen? Let's also see that image. Okay, so see here in this image, you can see that the contact now has broken. Okay, you can clearly see in this figure that the contact between the 2 contact points has broken here. Okay, so instead of that, look here, the primary current was flowing through this contact breaker. ठीक है, अगर primary current की हम बात करते हैं, the primary current was actually flowing through this contact breaker. Once these points were in contact, the current was flowing through this. Now once this contact has broken here, okay, by the action of the cam, you can see that this portion of the cam is touching with the heel. ठीक है, ये कल भी हमने देखा था that this is the heel. Okay, and this complete arm is the pivot arm. So you can see that the cam has touched this portion of this heel and the contact has broken. Now once the contact has broken, see here, this current now will flow through this capacitor. Okay, this current will now flow through this capacitor and it will charge the capacitor. So what can we see here, when the breaker point is open, when the breaker point is open, by the action of the cam, okay, the current which was flowing through the contact breaker, the current which was flowing through the contact breaker, initially the current was flowing through the contact breaker, will now instead starts flowing through the capacitor. Okay, it will start now flowing through the capacitor. And what happens here, as the capacitor charges, as capacitor charges, the primary current falls. Okay, you can see that the primary current is falling here. The primary current will fall. The primary current falls and the magnetic field starts to collapse. Magnetic field starts to collapse. Okay, you can see that the strength of the magnetic field is now collapsing. यहाँ पे क्या represent करता है? If you see the previous slide here, the magnetic field was quite strong. Okay, the magnetic field was quite strong because this was the primary current which was flowing through the circuit breaker. Now here what will happen, gradually during the charging of this capacitor, the primary current will go on decreasing. Okay, and this capacitor will go on in, इसका charge क्या हो जाएगा, इसकी across जो voltage हो जाएगी, that will go on increasing and its voltage will be higher than that of the battery. ठीक है, इसकी जो voltage and develop होगी, that will be higher than that of the voltage in the battery. ठीक है, so at a time will reach that current will completely disappear. Okay, the primary current will completely fall. Okay, as the charge, as this capacitor is charging, the primary current is going to decrease, and at a point this primary current will completely fall. So here, see here, since this magnetic field is collapsing, okay, therefore this change in the magnetic field, this change in the magnetic field induces a current in the primary coil. This change in magnetic field induces a current in the primary winding, which flows in the same direction as that of primary current. Which flows in the same direction as that of primary current. And charges the capacitor, and it charges the capacitor to a voltage much higher than the battery voltage. than the battery voltage, and thus leading to the stop of the current, and thus leads to the stop of the current flowing from the battery. Okay, so gradually the current that was flowing from the battery will go on stopping. Okay, once this magnetic field is going to decrease, okay, the primary current will go on decreasing, and it will charge the capacitor and the magnetic field will collapse. Okay, so at a point will now reach when there is zero primary current. Okay, when there is zero primary current and the magnetic field has collapsed completely. उसके बाद क्या होगा? उसके बाद then the capacitor, now which has charged to a very high voltage, okay, it has charged to a quite high voltage than the battery, will do what? It will start reversing the current. Okay, now you can see here what is happening here. The contact has broken here. The capacitor has charged to a certain degree of voltage which is quite larger than the battery voltage. Now there takes place the discharging of the capacitor. Okay, there will be the current now in the opposite direction. Okay, there will be now the current in the opposite direction. Okay, so due to this the capacitor discharges into the battery. Capacitor discharges into the battery, thus reversing the direction of both primary current and the magnetic field. Okay, so this rapid collapse of the magnetic, this rapid collapse. Okay, so in short, now this overall collapse of the magnetic field magnetic field and its reversal. Okay, and its reversal induces a very high voltage, in the secondary winding of the ignition coil. In the secondary winding of the ignition coil. So the main aim of this circuit was to bring about the abrupt change in the magnetic field. Okay, therefore when the magnetic field changes in a very short instant of time, so ये जो circuit है, ये जो भी आपने process देखे हैं, so ये एक second में बहुत बार होता है. So this time interval dt is very small. Okay, that's why we are able to get what abrupt change in the magnetic field. Once we have reversed the direction of the magnetic field, we are getting the magnetic field reversal, and that too in a very short instant of time, which will help in developing very high EMF, because we have seen that it is proportional to the change in magnetic field and inversely to the time interval. Okay, so this was the main aim of this circuit. Okay, and later on this thing is what this thing is transferred to what this induced EMF is transferred to the distributor coils. Okay, this is a high tension wire which is transferring this to the, तो जो मैंने कल वो सर्किट दिखाया था पूरा, अब ये सेकेंडरी वाइंडिंग से जो ये कनेक्शन निकलता है, it will be of the high voltage and it is transferred to the distributor, and which will regulate the and we should further transfer this voltage to the required spark plug at a time. So this is all about the battery ignition system, but I want you to study another ignition system yourself, that is another magnification in this ignition system, that is the magneto ignition system. ठीक है, तो आपने बेसिक सब्जेक्ट्स पढ़े हैं इलेक्ट्रिकल के, सो दिस वोंट बी दैट मच डिफिकल्ट फॉर यू. सो बहुत बच्चों को तो कल ही समझ आया होगा दैट बाय द सर्किट डायग्राम ही कि कैसे ये फंक्शन करता होगा. सो थोड़ा बहुत मैंने आज डिस्कस किया, बट द सेकंड काइंड ऑफ इग्निशन सिस्टम दैट यू कैन इजीली अंडरस्टैंड इज द मैग्नेटो इग्निशन सिस्टम दैट यू विल लुक फ्रॉम द बुक. ठीक है, दोनों बुक्स पे है. The book which I provided you, you can see that these both are in the book. Okay, so just wait a second. So let's focus now the discussion on another term or another field, that is carburetor. Okay. So what is actually the carburetor? And this is the term that is associated with the spark ignition engines. You will never see the carburetor in the CI engines. Okay, and this is quite now an old technology, but still it helps us to it helps in explaining the various things. Okay, तो आजकल आप देखोगे कि कार्बोरेटर मॉडर्न इंजन्स में होता नहीं है. ठीक है, उसमें भी क्या होता है, फ्यूल पोर्ट्स होते हैं. फॉर द इंजेक्शन देयर आर पोर्ट्स. ठीक है, so carburetor you can see usually in nowadays, usually you can see in the two wheelers, usually in the two wheelers, but most of the now जो भी engines आते हैं अब, you can hardly you can see the carburetor, but it is a quite a classical term, therefore it is usually studied. Okay, although this has been replaced by the ports. Okay, ignition जो होता है वो port से होता है, but we still have to study the carburetor. And so first of all we will define what carburation. तो मैंने इससे पहले भी क्या डिस्कस किया है आपके साथ. कार्बोरेशन होता क्या है? इट इज एक्चुअली द कार्बोरेटर इज अ प्लेस वेयर व्हाट a homogeneous fuel air mixture forms. Okay, so we can see that the process of carburation is actually the process of forming a combustible fuel air mixture. Okay, the process of forming a combustible fuel air mixture by mixing the proper amount of fuel with air before admission to the end, before admission to the cylinder. Okay, so what is carburation? The process of forming a combustible fuel air mixture by mixing the proper amount of fuel with air before admission into the cylinder. Okay, so for the different operating conditions of the vehicle, we need different fuel air mixtures. Okay, we will gradually see what are the various fuel air mixtures. Okay, and we need this fuel air and air mixture. You know that the fuel will mixture with the air, but it should mix in some proper proportions. Okay, it should mix in some proper proportions, and that we can obtain with the help of this carburetor. Okay, so therefore I have just written that definition, that the process of forming a combustible fuel air mixture, first of all it should get combustible. ठीक है, उस proportion में ये mix होना चाहिए that it is able to get combusted. Therefore, I have written by mixing the proper amount of fuel with air before admission to the cylinder. Okay, the device which is used to okay, so the device which is used to obtain this mixture is known as the carburetor. So carburation is the phenomenon, and the device which by which we employ this carburation, that is known as the carburetor. And we can see one schematic of this carburetor, how the working principle इसका अगर हम देखेंगे, this is how the carburetor looks like. Okay, इसमें क्या होता है, एक पाइप होती है. So I will discuss these things later on, but roughly you can see that there is this carburetor is in the form of a pipe. और यहाँ से क्या आता है, यहाँ से एटमॉस्फेरिक एयर आता है. ठीक है, यहाँ से एटमॉस्फेरिक एयर आता है. And this section here is known as what, venturi. You can see that at the section AA. At this section AA, you can see that the area is large. And if this is the section BB, okay, this is the section BB here, which is known as the throat of the venturi. This is the throat section. It has its area is less, okay, very less area as compared to the area of the section AA. ठीक है. So यहाँ पे क्या होगा, less area जहाँ पे होता है, you know that there is a quite high velocity, because you know there is a continuity equation that A1 V1 is equal to A2 V2. Okay, you can see that at the section 1 area is quite large, therefore velocity will be less. To conserve this, okay, this is what conservation equation. आप देख सकते हो एरिया का यूनिट क्या होता है, एरिया का यूनिट होता है मीटर स्क्वायर, velocity का यूनिट होता है मीटर पर सेकेंड. So if we combine them, we will get this unit meter cube per second. That is, it is actually what, वॉल्यूम पर सेकेंड, कितना वॉल्यूम ऑफ एयर फ्लो हो रहा है पर सेकेंड. एंड दिस इज नोन एज व्हाट, डिस्चार्ज. दिस इज नोन एज व्हाट, डिस्चार्ज. ठीक है, तो दो किस्म के डिस्चार्ज होते हैं, आपने पढ़ा होगा स्टेडी फ्लो एनर्जी इक्वेशन में. वन डिस्चार्ज इज इन व्हाट, मीटर क्यूब पर सेकेंड. ओके, एक डिस्चार्ज का यूनिट होता है मीटर क्यूब पर सेकेंड. उसमें फॉर्मूला जो होती है, दैट इज द एरिया ऑफ द फ्लो, किस एरिया के अक्रॉस से फ्लो हो रहा है, मल्टीप्लाइड बाय द वेलोसिटी. सेकेंड डिस्चार्ज इज इन द फॉर्म ऑफ द मास डिस्चार्ज. ठीक है, इसको हम कहते हैं कभी, this thing is sometimes known as what, volumetric flow rate. Volumetric flow rate से ही पता चलता है that how much volume is flowing per second. Therefore its unit is meter cube per second, because meter cube belongs to the unit of volume. Second discharge is in the form of, second discharge is in the form of mass flow rate. सेकेंड डिस्चार्ज इज इन द फॉर्म ऑफ अ मास फ्लो रेट. ठीक है, तो किसी भी फ्लो का अगर हमें डिस्चार्ज मेजर करना है, आइदर वी कैन मेजर इन द वॉल्यूम पर सेकेंड और वी कैन मेजर इन द फॉर्म ऑफ केजी पर सेकेंड. और इसका जो यूनिट होता है मास फ्लो रेट, it is what, density into area into the velocity. Okay, multiply it with density, you will get this mass flow rate. Because you can see that density का area क्या होगा, kg per meter cube, area का यूनिट है, एरिया इंटू वेलोसिटी का यूनिट क्या है, वो हमने अभी देखा, मीटर क्यूब पर सेकेंड. This meter cube and meter cube will cancel, we will get this flow rate in the kg per second. Therefore this is actually what, mass flow rate. ये आपने देखा होगा स्टेडी फ्लो एनर्जी इक्वेशन में जो आपने पढ़ी है, SFEE. दैट इज द फर्स्ट लॉ ऑफ थर्मोडायनिक्स फॉर द क्लोज्ड सिस्टम. ठीक है, स्टेडी क्या मतलब क्या है कि जितना मास एंटर होगा सिस्टम में उतना ही लीव होगा. देयरफॉर वहां पे हम लिखते थे दैट द मास एंटरिंग, मास इनलेट इज इक्वल टू मास एग्जिट. तभी जाके हम कहेंगे इट इज अ स्टेडी फ्लो रेट. दैट इज द मास फ्लो रेट इज नॉट चेंजिंग विद टाइम, दैट इज दिस डिफरेंशियल विल बी जीरो. ठीक है, ये आपने देखा होगा, आपने बड़ा वहां पे पहले ये पढ़ी होगी. आई मीन टू से दैट जनरल एनर्जी कंजर्वेशन इक्वेशन, दैट इज जनरल कंजर्वेशन इक्वेशन. उसमें टाइम के टर्म्स भी आते हैं. फिर आपने डेरिवेशन में क्या किया होगा, इस मास फ्लो रेट टर्म को, इसका डिफरेंशियल जो होगा उसको आपने जीरो किया होगा. ओके, इन द steady flow energy equation, neither the energy gets accumulated nor the mass gets accumulated. ठीक है, so जितनी energy आती होगी into the system, that is the energy which is what, leaving the system. Okay, similarly is the case with the mass. Only then first of all we deal with the general energy equation, then we put this time terms हम neglect करते हैं for the steady case, इसलिए हम लिखते हैं फिर steady flow energy equation. Okay, therefore we have two kinds of discharge, one is the mass discharge and another is the volumetric flow rate. You can see here, this is the venturi which has the low क्रॉस सेक्शन, यहाँ पे क्या है, एरिया ऑफ क्रॉस सेक्शन इज लो. सी हियर एट द इनलेट, जहाँ पे ये एयर आता है इनटू द सिस्टम, area is high, the velocity will be low. And here at this, now at this instant, at this venturi section here, you can see that area is low but the velocity will be high. और बर्नौली से हमें ये भी पता चलता है कि जहाँ पे हाई वेलोसिटी होगी वहां पे प्रेशर कम होगा. ठीक है, देयर इज अनदर इक्वेशन, दैट इज द बर्नौली इक्वेशन. You will be aware of that. P by rho g plus v square by 2g, okay, is equal to 0. जहाँ पे velocity ज्यादा होगी, at the section we have high velocity, यहाँ पे कम क्या होगा, यहाँ पे कम होगा, प्रेशर कम हो जाएगा. ठीक है, तभी जाके यहाँ पे जो प्रेशर होगा, तभी जाके फ्यूल क्या है यहाँ से आएगा यहाँ पे. ठीक है, ये क्या है, दिस इज द फ्यूल चैम्बर. ठीक है, फ्यूल की टैंकी यहाँ पे कनेक्ट होती है, दिस इज द फ्यूल टैंक जिसमें फ्यूल भरा जाता है, वो फिर आता है इस चैम्बर में, दैट इज नोन एज व्हाट, फ्लोट चैम्बर. तो यहाँ से जाके फ्यूल उठ जाता है, यहाँ से एयर आता है, यहाँ से फ्यूल आता है, एंड वी विल गेट a fuel air mixture. Okay, we will get a fuel air mixture, but this has to be controlled. ठीक है, this has to be controlled. यहाँ पे आप देखोगे there is a term that is known as throttle valve. Okay, I have to discuss this thing again in detail later on, but I will start discussing what is the fuel air mixture और requirement क्या होती है different conditions पे. This is the throttle valve. Simply आप कह सकते हो this is controlled by accelerator. ठीक है, दिस इज द थ्रोटल वाल्व विच इज कंट्रोल्ड बाय एक्सेलरेटर. आपको पता है कि एक्सेलरेटर, ठीक है, जब आप कुछ भी एक्सेलरेटर नहीं दबाते हो उस टाइम थ्रोटल वाल्व क्या होगा, कुछ इस कंडीशन में होगा, दिस विल बी थ्रोटल वाल्व. ठीक है, आई मीन टू से थ्रोटल वाल्व पूरा क्या है, एक्सेलरेटर. बाइक्स वगैरह में क्या होता है, राइट हैंड पे होता है वहां पे एक्सेलरेटर जिसको आप कहते हो, और कार्स में कहाँ पे होता है, इन द दैट इज बीन ड्रिवन बाय दिस फुट. ठीक है, तो जितना आप एक्सेलरेटर इंक्रीज करते हो उतना थ्रोटल वाल्व खुल जाएगा. ठीक है, अभी इस कंडीशन में क्या होगा, इट इज ऑलमोस्ट क्लोज्ड, बट व्हेन यू विल अप्लाई a good deal of accelerator, what will happen, this means that you have applied the full accelerator. ठीक है, throttle valve ये पूरा खुल गया. So this throttle valve is nothing but it is controlled with the help of the accelerator. It is controlled by the person with the help of the accelerator. This thing is one throttle valve. And another thing is that here choke valve. ठीक है, जब हम पढ़ेंगे ये कोल्ड कंडीशन स्टार्टिंग, ठीक है, विंटर्स में आपने देखा होगा दैट वी हैव टू अप्लाई चोक फर्स्ट. ठीक है, ये चोक भी क्यों अप्लाई होगा ये हमें सारा देखना है पहले इसका मैथमेटिकल एनालिसिस में. ठीक है, so I will discuss this figure again when I have to discuss the analysis of this carburetor. But before moving, so this is the rough idea of the carburetor. एयर आता है यहाँ पे, एयर का प्रेशर जो है वो यहाँ पे कम हो जाता है. मैंने बताया प्रेशर क्यों कम होगा, बिकॉज वेलोसिटी यहाँ पे ज्यादा हो जाएगी और प्रेशर कम हो जाएगा. तभी जाके यहाँ से भी क्या होता है, ये जो फ्यूल चैम्बर होता है यहाँ पे वेंट होता है. ओके, देयर इज अ वेंट, दैट इज इट इज अगेन कनेक्टेड टू द एटमॉस्फेयर. तो इस पे भी जो प्रेशर होगा वो कहाँ पे होगा, वो भी होगा एटमॉस्फेरिक प्रेशर. इसीलिए यहाँ पे क्या होना चाहिए, कम प्रेशर होना चाहिए देन द एटमॉस्फेरिक एयर. देयरफॉर वी क्रिएट दिस वेंचुरी in order to reduce the pressure of the air less than the atmospheric pressure. तभी जाके फ्यूल क्या आ जाएगा, यहाँ से इस फ्लोट चैम्बर से उठ के यहाँ पे फ्यूल आ जाएगा, and we will get a mixture, and that mixture will also be controlled by the throttle valve. Okay, depending upon, आपको पता है ना, जहाँ पे पार्किंग होगी, suppose you are at the traffic signal, the throttle will remain almost completely closed because you are not pushing the accelerator. Okay, and when you are moving on the highway, the throttle valve will be quite काफी ओपन हुआ होगा. ओके, अराउंड 60, 70, 80% तक थ्रॉटल वाल्व ओपन हुआ होगा. एंड व्हेन यू हैव टू रिक्वायर वेरी हाई पावर रिक्वायरमेंट, उसमें more than 80% throttle valve open होता है. ओके, एंड वी विल आल्सो स्टडी व्हाट इज द फंक्शन ऑफ द चोक वाल्व. ठीक है, चोक आपने देखा होगा कि अक्सर जब भी हम विंटर में हमें गाड़ी स्टार्ट करने से पहले या बाइक स्टार्ट करने से पहले हमें ये चोक वाल्व यूजुअली दबाना पड़ता है. ओके, सो बिफोर मूविंग द कार्बोरेटर, तो उससे पहले हमें पढ़ना है फ्यूल एयर रेशियो. ओके, वी हैव टू स्टडी व्हाट इज द फ्यूल एयर रेशियो. सो फ्यूल एयर रेशियो इज एक्चुअली व्हाट, in fact we will study air fuel ratio. तो एयर और फ्यूल की मिक्सिंग होनी है, तो किस रेशियो में मिक्स हो जाएंगे, दैट इज नोन एज व्हाट, एयर फ्यूल रेशियो. ओके, So air fuel ratio, I can write that it is before studying carburetor, we have to understand these terms. Okay, air fuel ratio is the mass of the fuel. Okay, sorry, mass of the air. It is actually the mass of the air to the mass of the fuel. Okay, so there are three types of air fuel ratios. Okay, there are three types of air fuel ratios which we have to study. First air fuel ratio is a chemically correct air fuel ratio, and this is also known as stoichiometric ratio. Second fuel air ratio is rich. Okay, रिच मिक्सचर, उस टाइम क्या फॉर्म होता है, रिच मिक्सचर फॉर्म होता है. एंड थर्ड इज व्हाट, another is what, lean mixture. So we have to study all these three. So how we define this chemically correct air fuel ratio? It is the ratio, it is that ratio in which there is just enough air for complete combustion of the fuel. Okay, so what is this chemically correct air fuel ratio? It is defined as the, and if we have mixed the fuel and air in this proportion such that the mixture formed is a chemically correct mixture, then we say that there is just enough air for the complete combustion of the fuel. Okay, that is, there is enough air. Okay, for the combustion of the fuel what we require is the oxygen, but that oxygen should be in some proper proportion. ठीक है, तो कम से कम इतना ऑक्सीजन होना चाहिए, इतना एयर होना चाहिए, so that we are able to burn what, complete, there is the complete combustion of the fuel. And what does this complete combustion of the fuel actually mean? This complete combustion means what? And this complete combustion here actually means that is, फ्यूल में क्या होगा, कार्बन होगा, और होगा क्या प्रेजेंट, हाइड्रोजन होगा. The complete carbon should be converted into the carbon dioxide and complete hydrogen should be converted into the water. Okay, that is the complete burning of the fuel should take place. Okay, that's why when we say that it is the complete combustion of the fuel, therefore we should have just enough air. Okay, chemically correct mixture is known as the mixture in which there is just enough air for the complete combustion of the fuel. Okay, so such a mixture is also known as what, stoichiometric mixture. This mixture is also known as what, stoichiometric mixture. That is, there is enough oxygen, just enough oxygen for the complete combustion of the fuel. ठीक है, सो ये रेशो जो होता है गैसोलीन के लिए क्या होता है, that is for burning 1 kg of petrol, for burning 1 kg of petrol, we need, at least we need what, 15.12 kg of air. Okay, 15.12 kg of air. Therefore this stoichiometric or chemically correct air fuel mixture has a air fuel ratio of 15. ठीक है, फॉर गैसोलीन इट इज इक्वल टू 15. ठीक है, डीजल के लिए शायद 14.8 होता है, आई डोंट एग्जैक्टली रिमेंबर, बट वी टेक दिस टू बी, वी राउंड ऑफ इट टू बी 15. ओके, so this is what, this is the chemically correct mixture or stoichiometric mixture, which is what, which is defined as the ratio of the air and fuel, so that complete combustion of the fuel will take place. Okay, and that is 15 kg of air is just enough for the complete combustion of 1 kg of the fuel. Okay, so another mixture is what? Rich mixture. Second thing is that what? That is known as what? Rich mixture. Okay, rich mixture इसमें define होती है, richness is defined. Rich मतलब क्या? Rich means here petrol, this fuel is more. Rich here means fuel is more. Rich here means what? Fuel is more than what? Than the stoichiometric requirement. ठीक है, fuel is more than the stoichiometric requirement. So इसमें क्या होगा अब? Rich, if the mixture is rich, that is what it means, that the fuel is more than the required quantity. तो rich air mixture fuel, इसका जो air by fuel ratio होगा, that will be less than 15. Okay, this will be less than 15. The rich fuel air mixture will be what? Less than 15. This will be what? Less than 15. So any fuel air mixture जिसमें ratio क्या होगा? Air to fuel का ratio होगा less than 15, that will be known as what? A rich mixture. It means that, okay, आप खुद से देखो, अगर हम fuel by air की बात करते हैं, okay, fuel by air की बात करते हैं, for the stoichiometric conditions, fuel by air should be what? Sorry, fuel by air should be 1 by 15. Fuel by air should be what? 1 by 15. ठीक है, this is air by fuel, and fuel by air should be, okay, it is generally, this ratio is generally 12 is to 1 or 10 is to 1. Okay, any value which can be less than 15. 15 is to 1, 15 by 1 से जो भी कम होगा, तो फ्यूल और एयर का जो मिक्सचर होगा, इसका रेशियो जो होगा, दैट इज विल बी 1 by 15. दिस इज स्टोइकोमेट्रिक और केमिकली करेक्ट. अगर हम बात करते हैं फॉर ए रिच मिक्सचर, ओके, फॉर ए रिच मिक्सचर, तो उसका वैल्यू क्या होगा? दैट विल बी 1 by 12. सपोज एक फ्यूल एयर रेशियो होगा, दैट इज 12 is to 1, देन फ्यूल बाई एयर का क्या होगा? 1 by 12. Okay, air by fuel is 12 is to 1. If we take it reversal of it, then fuel by air ratio is 1 is to 12. Okay, so यहाँ पे देखो केमिकली करेक्ट में क्या होना चाहिए? केमिकली करेक्ट में क्या होना चाहिए? केमिकली करेक्ट में अगर 1 kg हमें चाहिए फ्यूल का बर्न होने के लिए, 15 हमें चाहिए, ठीक है, बट हियर ही सेज दैट दिस condition refers that there is a richness in the fuel, richness of fuel, that is fuel available is more, ठीक है, fuel available is more. Therefore, this richness of the mixture is actually in terms of the availability of more fuel. Okay, so this is the rich mixture. The last mixture which we have to see here is the lean mixture. Lean mixture में क्या होगा? The air fuel ratio is greater than the stoichiometric ratio or chemically correct ratio. That is, in this case, what we will have here, the fuel air mixture will be more. Sorry, air to fuel mixture will be greater than 15, which means what? स्टोमेटिक कंडीशन से ज्यादा होगा एयर, ठीक है, इसमें क्या होगा? वॉट एवर वी नीड फॉर द कंप्लीट कंबशन, उससे ज्यादा हमें होगा, ठीक है. सो इसमें क्या होता है? लीन इज एक्चुअली व्हाट? लीन का मतलब क्या है यहाँ पे? दैट फ्यूल इज लेस. ओके, इस कंडीशन में क्या होगा? फ्यूल विल बी less here in the mixture, the fuel will be less than the stoichiometric requirement, ठीक है, but still it is enough for what? Combustion, ठीक है. इसमें क्या होगा? 17 is to 1, suppose mixture होगा 16 is to 1. These are the air fuel mixtures, okay, 19 is to 1. And there is a limit also, we can't go beyond certain mixtures. I can show you this. ठीक है, Combustible range क्या होगा? We can put it here 15. ठीक है. So what are the limits of the air fuel ratio? Okay, not, it should not be less than 9 nor greater than 19, because here, see here, this will actually be, okay, sorry, this is actually 15 here, 15 यहाँ पे लिखना था. This is the stoichiometric ratio. This is actually here 19. ठीक है, यहाँ से 19. This will go on increasing and this will go on decreasing. ठीक है, so combustible range क्या है? The air fuel ratio should be for the proper combustion. What should be the fuel air ratio? Here we should have this should vary between what, 9 to 15. Okay, 9 to 19. Sorry, 9 to 19. Although this 15 is what, the chemically correct ratio, but we can use these ratios as well for the combustion. ठीक है. So what happens here if we go below this air fuel ratio? अगर हम below 9 जाते हैं, the mixture becomes too rich to burn. ठीक है, तो इतना ज्यादा पेट्रोल आ जाएगा उसमें, है ना, मिक्सचर ज्यादा रिच हो जाएगा. रिच होना मतलब दैट देयर विल बी मोर फ्यूल सप्लाई. After going, after the air fuel ratio becomes less than 9, there won't be enough oxygen to burn the fuel. Okay, therefore its combustion will not take place. Again, this will be what, too lean to burn. ठीक है, एयर बहुत ज्यादा होगा, फ्यूल कम होगा, इसमें भी क्या होगा, it won't be able to burn. Therefore the combustible range is what, 9 to 15. Okay, this is the combustible range. So these are the various fuel air mixtures. Okay, तो हमें कहीं पे रिच मिक्सचर चाहिए होता है, कहीं पे हमें क्या चाहिए होता है, लीन मिक्सचर. दैट्स व्हाई वी हैव टू control this air fuel ratio. This air fuel ratio should be controlled as per our requirement. देखिए, जब हम किसी हाईवे पे क्रूज कर रहे हैं, देयर आर थ्री रेंजेस वी हैव टू स्टडी. वन इज द आइडलिंग रेंज. कहीं पे हमने गाड़ी पार्क की है, ठीक है, ट्रैफिक लाइट्स आ गए, वी हैव पार्क्ड आवर कार. ओके, इंजन इज रनिंग बट वी हैव पार्क्ड आवर कार, वी आर वेटिंग फॉर द ग्रीन सिग्नल. उस टाइम क्या होगा, उस टाइम हमें रिच मिक्सचर चाहिए होता है. दैट टाइम वी नीड व्हाट, रिच मिक्सचर. कहीं पे हम किसी गाड़ी को हमें ओवरटेक करना है, दैट इज वी नीड मोर पावर. मोर पावर का मतलब है, अगेन देयर इज द रिक्वायरमेंट ऑफ द रिच मिक्सचर. एंड इफ वी आर क्रूजिंग ऑन अ हाईवे एट सम नॉर्मल स्पीड, एट सम मॉडरेट स्पीड, ठीक है, उस टाइम हमें क्या चाहिए होता है, उस टाइम हमें चाहिए होता है दैट वी डोंट नीड द हाई एयर फ्यूल मिक्सचर, वी नीड व्हाट, we need this lean mixture. Okay, we need what, lean mixture. उस टाइम क्या हमें जरूरत होता है, we need the lean mixture. So यहाँ से देखो, this is the 15. यहाँ से क्या हो जाएगा, अगर हम ज्यादा अब लीन जा रहे हैं, so the mixture becomes lean. अगर हम towards left side जा रहे हैं, the mixture becomes rich. Okay, and 15 is what, chemically correct mixture. So in short what I want to say that the fuel air requirements will vary. ठीक है, तो ये आर्बिट्रली किसी भी मिक्सचर, किसी भी रेशियो में मिक्स नहीं होता है. तो कार्बोरेटर का काम ही है दैट वी नीड द मिक्सचर इन सम प्रॉपर प्रोपोर्शंस, है ना. सो इफ यू रिकॉल द डेफिनेशन, अगर आपको डेफिनेशन रिकॉल करनी होगी, बाय मिक्सिंग द प्रॉपर अमाउंट ऑफ फ्यूल विद एयर as per the conditions. Okay, as per the conditions, sometimes we need rich mixture, sometimes we need lean mixture, and later on we will see कहाँ पे हमें ज्यादा जरूरत होता है rich, कहाँ पे lean mixture की जरूरत होती है. Therefore it's the function of the carburetor to mix it in the proper proportions. और वो कंट्रोल कैसे होगा, वो थ्रॉटल से कंट्रोल होगा, वो सारा थ्रॉटल से कंट्रोल हो जाएगा. So again there is some terms here. Mixture corresponding to maximum power output, corresponding to maximum power output. And this mixture is usually what, obviously जहाँ पे हमें maximum power चाहिए, वहाँ पे क्या होना चाहिए, वहाँ पे rich mixture होना चाहिए. तो air fuel ratio should be 12. Okay, mixture corresponding to maximum power output, the air fuel ratio should be what? It should be 12. And mixture corresponding to minimum BSFC, mixture corresponding to minimum BSFC. Okay, BSFC means what? Break specific फ्यूल कंजप्शन. ठीक है, इसका मतलब क्या है? मिनिमम ब्रेक स्पेसिफिक फ्यूल कंजप्शन मीन्स व्हाट? बेस्ट इकोनॉमी. ठीक है, बेस्ट इकोनॉमी वेयर वी विल गेट द मैक्सिमम माइलेज. ठीक है, मैक्सिमम माइलेज. अब देखो जो भी होता है किसी व्हीकल में जो मैनुअल होता है उसमें लिखा होता है दैट व्हाट इज इट्स माइलेज. ओके, सपोज 20 किलोमीटर्स पर लीटर, बट दैट इज ऑफ द बेस्ट इकोनॉमी. ओके, इट विल वैरी अकॉर्डिंग टू द ऑपरेटिंग कंडीशंस. ठीक है, कहाँ पे आप चल रहे हो, किसी हाईवे पे चल रहे हो या किसी ट्रैफिक जैम में चल रहे हो, इट विल वैरी. बट जो मैक्सिमम देगा दैट इज व्हाट इज मेंशन्ड इन द मैनुअल. सो बेस्ट इकोनॉमी के लिए, बेस्ट माइलेज के लिए जो एयर फ्यूल रेशियो होता है दैट इज 16. दैट इज इक्वल टू 16. सो मैक्सिमम पावर आउटपुट के लिए क्या होना चाहिए? वी द एयर फ्यूल रेशियो इज rich. Okay, because this is the rich, and here, sorry, this is the lean here. Okay, this is the lean and this is the rich. So you can also see this graph here. ठीक है, एयर फ्यूल रेशियो यहाँ पे एक्सिस पे प्लॉट किया गया है, यहाँ से पावर आउटपुट प्लॉट किया गया है. So you can see that the maximum power output, this is the maximum power output curve. It is what? It is maximum at what fuel air ratio? You can see it is maximum at 12. एंड दिस इज द ब्रेक स्पेसिफिक फ्यूल कंजप्शन. जहाँ पे आपको ज्यादा पावर आउटपुट चाहिए वहां पे फ्यूल भी कंज्यूम ज्यादा होता है. और बेस्ट इकोनॉमी के लिए क्या चाहिए? फ्यूल एयर रेशियो. सी हियर, दिस इज द कंजप्शन करो. ठीक है, फ्यूल कंजप्शन, स्पेसिफिक फ्यूल कंजप्शन, कितना कंज्यूम हो रहा है फ्यूल. ओके, यू कैन जस्ट रिलेट इट टू द माइलेज. इट इज मिनिमम व्हेन, ओके, फ्यूल कंजप्शन ज्यादा होना मीन्स व्हाट? माइलेज इज लेस. ओके, सो यू कैन सी दैट जहाँ पे ज्यादा फ्यूल कंज्यूम हो रहा है, सॉरी सबसे कम फ्यूल कंज्यूम हो रहा है यहाँ पे. ओके, यहाँ पे सबसे कम फ्यूल कंज्यूम हो रहा है, दैट इज दिस द पॉइंट ऑफ द बेस्ट इकोनॉमी, एंड द एयर फ्यूल रेशियो हियर इज 16. Okay, so this is something regarding the air fuel mixture. So I think this is sufficient for today. I think this is sufficient for today.